All right. So I'm going to do the slab and the beam layout right away. Now, you know, the ground floor, the first floor, they are actually the same. So the only difference is in the cantilever, like I said. Okay, so I'm going to delete some of these files. I'm going to turn off some of this. Then I'll delete this. I'll lay on. Okay. I'll erase all of this at the slab and beam layout. I don't need this. I don't need all of this. So if they are in layers, they will actually make your work much more easier. You can see how I was able to turn off these layers that we are seeing right now, and we deleted those other ones easily. All right. So here now I'm going to type in my slab and beam layout. I'm going to give my beams a name. Each of these beam, I will name them, okay? So this is definitely going to be my floor beam 1. The cross section is 230 by 450 depth. Okay. So I will copy this. This is another beam. This is another beam. And then this is a beam. So this is beam 1, this is beam 2, this is beam 3, this is beam 4. So you can see here in AutoCAD, this is first floor, please. This is not ground floor. This is slab and beam layout. This is going to be at the first floor level. This is not at foundation, first floor slab / beam layout. So that is why it is called floor beam, not ground beam. So it's a floor beam, it's not a ground beam. So I'll change this name. So it boils down to your knowledge of AutoCAD, actually. So if you know how to use AutoCAD, all of this is just drafting. The basic thing you need is to understand the knowledge behind this, how to come about your general arrangement, how to detail properly, or how to interpret your detailed drawing rather. So if you understand that with the knowledge of AutoCAD that you have already, it's just to use that to come about your detailing. So there are some beams that will most likely be the same. Okay, like this beam now and this beam is definitely going to be the same. So there's no need of we giving them a different name. This beam and this beam is the same. And I think this beam is also the same. So 1, 2, 3, they are the same because they are carrying the same load. Look at the span here is 2,730. If you check the length from here to here, they have equal span. They are carrying equal span of slab. Look at so their loadings entirely are the same. Look at here, here, here. You discover they are the same. So it's actually the same load. So there's no need of you giving them a different name. So when you are coming up with your detailing, this beam, this beam, this beam is the same. Okay? Don't worry, let's move on so that you understand. This is 1, this is 2, this is 3, this is 4, this is 5. This is 6. This is 7. This is 8. This is 9. Oh, I'm sorry. I said this beam are the same. So they are going to be the same. They will carry the same name. But you know, in proto structure, it will give you a different name, even though these beams are the same, but it will carry different name. So this is beam 7. So it's not like it's wrong, but you know, we are just this particular beam, this beam, everything is the same. So this beam here, beam 7 here, and this other one are also the same. This beam and this beam is the same based on the loading it's going to carry. Okay, if you check the loading, that this beam and this beam are the same. Look at the span here, look at the length from here to here. So it's the same. So if we go down here now, here too, we are going to be having a lot of beam 6, 6, 6. So this is beam 6 also. Even here is going to be beam 6. Here is also going to be beam 6. Here too will be beam 6. All right. But this beam is going to be beam 8. And this one will be beam 9. All right. So I have 9 different types of beam in this particular building. So not unlike proto structure, it will tell you this is beam 1. Each span, it gives it a different name. It will tell you this is beam 1, beam 2, beam 3, beam 4, beam 5, beam 6, like that. This is a continuous beam. So it's carrying one name. This is actually also continuous. It stops here, carrying one name. This is another one. It stops here, it carrying another one name. Okay. Then this one goes carrying one name. Okay. But you can see this beam and this beam is not the same because of the loading. You can see the load of this slab. You can see how wide this one is. But you can see the slab here is not as wide as this one. So they are definitely ranging by eye. You know that this loading are not the same. But when you see a beam carrying identical kind of load, you know that that beam is definitely going to be the same. By the time you run your design, it's going to provide you the same size of reinforcement, the same spacing of your links, and everything that has to do with that beam, the cross section, everything is going to be the same. So there's no need of you giving them a separate name. They are the same. Okay, so that is the essence of giving it the same name. So like I said, this is beam 1, this is 2, this is 3, this is 4, this is 5, while 1, 2, 3 is beam 6, 1, 2 is beam 7, 1, 2, 3 is also beam 6, and this is beam 8, and this is beam 9. All right. So if all of that is correct, The next thing now is to insert the type of slab that we have here. So based on our design, we assumed a thickness of 150, and that 150 thickness of slab actually passed. Okay, so we are going to type in 150 thickness of slab. And if you look at this very well, you see that this is a two-way slab. This is telling you that this is two-way. You can see this line coming this way. You can see this line coming across it. So they cross each other. It's telling you that our reinforcement is coming this way and it's also coming this way. So we are going to be having our main bars along this length. We are also going to be having our main bars along this span as well. So let me do the small calculation and show you how to come about that. So all you do is to divide your Ly all over Lx. So your Ly means the long span, the Lx means the short span. So Ly, by the time you divide 4,000 divided by 2,730, so you can punch down that in your calculator and see what that will give us. So let me punch that in my calculator. So you discover that the value is going to be less than 2. Okay, 4,000 divided by 2,730. So you are going to be having 1.465, but approximately 1.47. So if that is correct, this value is actually less than 2. So anytime you have a value that is less than 2, is actually two-way. Anytime you have a value that is greater than 2, is actually one-way. So let's say, for example, this value is actually 6,000. So by the time you divide 6,000 divided by 2,730, you discover that you are having 2.978. Okay, so you can say approximately is 2.2. So by the time you have 2.2, is actually greater than 2. So in that case, that slab is going to be a one-way slab. So when we get to where we are supposed to have a one-way slab, I will demonstrate that and I will show you quickly. So this is actually a two-way slab. All these panels are actually similar to each other. So this is panel 1, but if you check this panel now, text edit, this is panel 2. But you discover, just like the way we did for our beam, you discover that this panel and this panel are actually similar. So this panel and this panel is similar. This panel 1, panel 2 here, and this panel 2 here, and this panel 2 are actually similar. You can see you have the short edge that is discontinuous. You have 3 edges that are continuous. 1 short edge is discontinuous. 1 short edge is discontinuous. 3 edges are continuous. But in this case, you see this panel, even though they have the same shape with this one, but it's different in that you have 2 adjacent edges that are discontinuous. This is actually a bit deep. You need to understand that part. I have talked about it very much well, most especially in my training on RCD 2000. All right, this panel now is going to be panel. This panel and this one are a bit similar as well. Okay, because this particular area where we have our staircase, our reinforcement will definitely return here. So our reinforcement is not entering the staircase from here. Our reinforcement will definitely return from here. So we can make this also panel 1. That is, this panel and this panel are actually the same. Okay, so here we are going to be having these to be panel 1 as well. While these are going to be panel 2, even by the time you do your design, this panel and this one will most likely provide the same size of reinforcement, the spacing and all, but it's going to be different. Okay, this panel is going to be different because if you check this span from here to here now is 2,730, but this one is 2,960. So this panel is going to be different because the span here is more than the other one. So this is panel 3. So if that is correct, that means even this beam that I named beam 6 is not correct. This is going to be beam 7 because it's going to be different. It's going to be different from this one because if you check the span from here to here now is the same, but when it gets to this place is different. So this particular beam will be different. So this beam will be 9. That is why you have to vet your drawing very well before you start, before you submit your design. All right. So this is another panel here. Now, this is definitely going to be a one-way slab because ranging by eye, you will see that this is looking very, 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 very cylinder. So if that is correct, but we have to punch that in our calculator to do that calculation manually to confirm if it's truly a one-way slab or a two-way slab. So you can see this span here is 4 meters, while this is actually 1,430. Even by merely looking at this, I know that definitely this is going to be a one-way slab. Okay, so but let's do that quickly right now. So if I divide 4,000 divided by 1,430, so you can punch that in your calculator. You are actually going to be having 2 point something. So let's punch that quickly. So if I multiply 4,000 divided by 1,430, so I'm having 2.797, which is approximately 2.8. So if that is correct, this is actually a one-way slab. So it's going to be like this. So your main reinforcement will span along the short span. So this is the short span. From here to here is the short span. So all our main reinforcement will go this way. Let me just trying to give you a sample of. So all our main reinforcement will span this way. So that is what it means by a one-way slab. So but if you have, in a case of two-way slab, you are having your main reinforcement along both the short span and also your long span. By the time we come to our slab detailing, you are going to see that better and understand that much more better. Okay. So, but I think this is actually a cantilever. Here also is a cantilever. So all of these are actually cantilever. All you need to do is just to, all the slab are similar to each other. Let's punch these and see. This is 2,730 divided by, if you punch that in your calculator, I think I'm going to have more than 2. It's going to be 2 point something, 2 point something, I think. 1, 2, 30. Good, it's 2.2. So all of these are also one-way slab. All of them, they are actually one way and they are actually cantilever. So there is a unique way of detailing a cantilever. By the time we come to our slab and beam layout, I'm going to show you how to properly detail. By the time we come to our slab detail, rather, you see how to actually detail your slab. Your cantilever slab is different from the way you detail your normal one-way slab, and it's also different from the way you detail your two-way slab. Okay, so all of these are actually different, and I'm going to be showing you all of that as we proceed in this training. Okay, so so they are definitely cantilevers, and they are all one way. So I'm going to copy that. So just give them a name. This is beam, this is slab 1, slab 2, 3. Okay, this is 1, 1, this is 2, 2, this is 1 also, this is 2, 2, this is panel 3, this is panel 4. So I can give it a name as panel 4. 4. This is 5. This is so I'm going to have this. This is 6. So this is definitely going to be the same with this one. This one might be different from this. One can be different. This one is also the same with that one. Then here I'm going to have the same panel here. Here. Then I'm going to have panel 7 here. But in paneling, there is a way you can make all of this to be continuous. Okay. Well, as we proceed, I'm going to be showing you all that. But right now, let's just detail this like a separate slab, all of them, each one separately, like they are all separate. Okay. I have just 4 minutes for this session to actually end. So I'll be fast to actually break this this tutorial right now, or this training right now. All right. So this is going to be a two-way. We are actually detailing all of this to be separate kind of panels. Okay, so they are all, we are detailing them as separate. But I said, as you proceed, you are going to see how to actually make your panels continuous. Okay, so but for now, let's assume we are designing all of this to be separate panels. Okay, so I'll end this right now, and then we'll continue in the next session.